Hi folks, I wanted to share some exciting news today that Sway AI is now integrated with the Snowflake data platform. So what exactly is Sway AI, and what does this integration mean for enterprises leveraging Snowflake today? Sway AI is a no-code AI and predictive analytics platform that enables analysts who may not be formally trained in AI to turn data into actionable and automated insights. With our easy-to-use Visual Design Studio, users are able to connect to their data, perform data exploration and preparation, train and evaluate models, and then deploy and manage their applications without having to write a single line of code or manage cloud infrastructure resources. Now, if this is your first introduction to AI, it might be helpful to see a quick demo, so let's dive in. This is an example of what we call a time series forecasting model. Now, in the Sway platform, you can use all different types of models to predict your data. You can use classification models, which are when you're predicting a binary target variable, for example, yes or no, will a particular customer churn or buy a particular product? Or a regression model where you're trying to predict a number. For example, what will the total sales be next month in dollars? Or how many days until a particular customer will buy a product? Or the third major use case is this one, which is a time series forecasting model. This is when we're trying to predict a future trend in either revenue or cost or whatever numerical variable you want to look at based on time-stamped historical data. So based on past trends, what do we predict the future trend to be? And you can see here we've connected to a Snowflake database. And if we click preview here, you'll see the first 1,000 rows of the data, and you'll see that we have 11 columns of data, a mix of numerical and text data. If you click here on column view, you'll see more information about the data, like the data types, whether they're integer or string or double, for example, the range for the numerical variables, so the min and the max, and then other variables around distribution, like the mean, the variance, the standard deviation. And then we'll even show you what percent of your data is missing and what percent of your data are outliers. Once we've connected to the data, the second step is to prepare our data for modeling. So if you go up here to data prep, you'll see there's all different kinds of options here. But some of the most common are if you want to filter your data to only model certain rows, or if you want to only select certain columns, or if you want to impute missing values with either the mean or the median or a zero, for example. You can even write your own custom SQL. There's a node for that. For example, if you wanted to create a new variable based on a combination of existing variables. So these are all the different data prep nodes we have available. We're adding more all the time. And then you can always click on each node after you've added it and click preview. And this will show you what the data looks like after it has run through that node. So the nodes run from left to right, from top to bottom, so in this way. And then the last step is you can add one or more machine learning models to make predictions based on your historical data. So there's a lot of models available here. All these models are available just for time series forecasting. If you had selected classification model to predict a binary target variable, you'd get a different list of models. And if you had selected regression, or what we call forecasting, you would get a still different set of models. So these models are all for time series forecasting. Just for simplicity, we selected one called a DARTS model. And if you click here on this design icon, you can see there's a couple important things we have to provide. One is the name of the date column. You always have to have a date column. You have to have timestamp data. So in this case, it's purchase date. And then what is the target that we're trying to predict? In this case, we're trying to predict sales quantity going forward. And we're trying to predict it at the daily level. And then this says basically that we want to group our forecast. So we don't just want the overall forecast of sales quantity. We also want it for particular demand families, which is basically a product category, or particular locations. So this will give us a prediction for each day going forward for each demand family location name combination. So that's what's happening here. And then the last step is you go up here to actually train the model, click train and evaluate, and when it comes back, it'll say trained. And then when the model's been trained, we can go in here and see how it performed. So we click on model metrics. This tells us the overall performance of the model, as well as some key performance indicators for both the 80% of the historical data that we trained the data on, called our training set, and more importantly, for the 20% of historical data we did not train the model on, so that we can use this as a good estimate of how the model will perform on new unseen data going forward. And then we see here, it shows us a nice graph of over time, the model's predictions versus the actual results. And then finally, if we click on Feature Insights, we can see how the model performed on that test or holdout set not used to train the model. So for example, here you can see what were the most important features or columns when it came to predicting our target variable. So in this case, these were the most important features. It graphs them out for you in order. And then the last thing I wanted to show you was you can create a nice dashboard for a nice visual approach to look at some of the key insights from your model. So in this case, let's say we wanted to look at total sales quantity forecast, which is our target variable, and then maybe we wanted to look at that for a subset. So this might be a particular product category, this might be a particular location, maybe for another location. You can do bar graphs, like for example, gross sales by location. So not just for sales quantity, which is our target variable that we're forecasting, but for other variables in the data set as well. Gross sales, for example. Inventory is another example. You can do pie graphs, donut graphs, line graphs. In this case, we have sales quantity trend by demand family or product category over time. And then finally, you can look at the data itself, and you can actually export your data and your predictions as a CSV file directly back into your platform of choice. You can just click here to go back to the platform. And it's really as simple as that. You could train multiple models at the same time and then compare the results of those models and select the one that performed the best. So thank you for staying with us. This is a good introduction to a time series forecasting workflow in the SWE AI platform, and we're excited to now be integrated with Snowflake. Thank you. If you're interested in learning more, please schedule a demo, and somebody like me or one of my colleagues would be happy to give you a deeper dive. Thank you.